About a year ago, I tricked my chemistry teacher into advertising my YouTube channel, and it worked. So I'm doing it again. Here we go. So today's mole day, right? You might have already known that. Well, moles are small mammals adapted to a subterranean lifestyle, i.e. fossorials. They have small cylindrical bodies, velvety fur, very small and conspicuous ears and eyes. Do you get it? Because mole sounds like mole, like the animal, but mole also like the number. You get it? It's so funny. Okay, first, let's get into why mole exists, right? So chemists want to keep track of the number of particles of each reactant or product in their experiments. And, well, using the mass just doesn't work. You know, if you were making magnesium sulfide, if you were to try to use the masses, 1 gram of magnesium doesn't neatly react with 1 gram of sulfur because their atomic masses are just so different. But 1 particle of magnesium does neatly react with 1 particle of sulfur. So we just gotta count by the number of particles, but... You know, actually, let's do an example here, right? If there's 37 quintillion particles of silicon oxide in an average grain of sand, get counting. This is where the mole comes in, right? My good friend Amadeo Avogadro once said, "Hey, I bet there's a number of particles that perfectly converts atomic mass units to grams." Sadly, Avogadro passed away before he could find this number, but his scientist friends continue the search for this number. So Avogadro's number is 6.0221415 times 10 to the power of 23, or 1 mole. 1 mole of hydrogen atoms, for example, would be 6.02 times 10 to the 23rd hydrogen atoms. With the power of mole, we can do anything as long as it's related to chemistry. It's a chemistry number. Why would we be able to do things that aren't related to chemistry? It doesn't make sense. You're being silly. 1 mole of magnesium does neatly react with 1 mole of sulfur to make 1 mole of magnesium sulfide. 2 moles of H2 plus 1 mole of O2 makes 2 moles of H2O. And you can do so much more, right? So like a molecule of water is 18 atomic mass units, but a mole of water is 18 grams. You see, you get it, you get it now, it's cool, right? A carbon atom is 12 AMU. A mole of carbon is 12 grams. The mass of a mole of a substance is known as its molar mass. And you can find that by literally just replacing atomic mass units with grams per mole. Boom, you got them. That's the molar mass, right? And you can find out how many moles of something there are by dividing the mass of a substance by its molar mass. If I have 50 grams of water, I can divide those 50 grams by water's 18 grams per mole molar mass to find that I actually have 2.778 moles of water. If you have a gas at standard temperature and pressure, then that gas's density will be 22.4 liters per mole. If you had 50 liters of oxygen at SDP divided by 22.4 liters per mole, that equal 2.232 moles of oxygen. If your gases aren't at standard temperature and pressure, then you can rearrange the ideal gas law to N equals PV divided by RT and plug in all your values. So, if you have a hydrogen gas in a 5-liter container at 3.0 atmospheres and 300 degrees Kelvin, you actually have 0.6093 moles of hydrogen gas. So now, we can use all these cool strategies that I've talked about to use stoichiometry, which is literally just converting things to moles and switching them back to mass or volume. It's actually pretty easy, right? You start with a value, convert it to moles, then use molar ratios to find out how many moles of another substance you need, have, or are going to have, then convert it back to a usable value. Let's say we have 70.9 grams of chlorine gas, it's Cl2, in the chemical formula for the formation of sodium chloride, and we want to find out how many grams of sodium we need to complete the reaction. 70.9 grams of Cl2 divided by Cl2's molar mass of 70.9 grams per mole equals 1 mole of Cl2. Whoa, that's awesome. The ratio of Na to Cl2 is 2 to 1, so to find moles of Na, we do 1 mole Cl2 times 2 mole Na per mole Cl2, which is 2 moles of Na. Then we multiply that by sodium's molar mass, which is 22.998 grams per mole, to get 45.996 grams of sodium. So you do the same process to find out how much sodium chloride this would produce, but this video is getting a bit long now, so you can work that out on your own if you actually care. But before you go, I need to tell you one last thing. The most important thing. Don't ever forget to subscribe to Spaghettayyyyyy. That's Spaghettayyyyyy. It's got 6 Y's, okay? Whenever people try to search it, they spell it wrong. They're like, it doesn't show. It's because you're spelling it wrong. You have to spell it perfectly right. Spaghettayyyy. I hope that made sense.